Rhea Roberts. Hey, State Fair, have fun. Do some calculus along the way. Reciprocal functions. We left off with all sorts of different types of functions, and we had a function such as we had y is equal to 1 over x. We had y is equal to 1 over x squared. That's the last part of our parent functions that we need to identify. Who remembers what 1 over x looks like? Good, excellent. Notice if you divide by what number, that's a problem. What number can you not divide by? What number can you not divide by? 0. So if x is 0, that's problematic, which is why you have this thing called a vertical what? Asymptote, okay? And so these reciprocal functions have interesting behavior, namely that they go like this and like that, okay? How's it going to change if it's 1 over x squared? If you square something, it's going to become what? It's going to become positive. So both things, instead of one being in the bottom, they're both going to be in the top. So I want you to look back at these. We've drawn all of our functions right now. Do you think you're going to be able to remember these shapes? Which one's the one you're most likely, parents share, which one are you most likely to forget? Which one are you going to forget? Talk.
Probably
5, 4, 3, 2, 1. Hannah, what are you going to forget?
Exponential and logarithm.
Okay, so you're gonna maybe forget these two right here. Okay. Steel trap. What are you gonna forget?
Actually, it was the exact same thing as mine.
Jada?
The same thing.
Aaron?
Yeah.
Really? Okay. So I guess my advice is just remember the exponential and from it come up with the logarithmic. But we need you to remember these. We flip over to, oh yeah, so we're going to go to the bottom of this guy. And now we're going to graph these. So you should be able to come up with graphs pretty quickly. So when we look at the parent function of x squared, what does that look like? Great, you remembered it. What's the minus 3 going to do?
Move it down 3.
Shift it down 3 units. So, that's something we practiced. You guys did really well with last year. Here I got the square root function. Is the minus 4 on the inside or outside? It's on the inside. So that's shifted horizontally or vertically? Horizontally. You can be to the right or the left. Right 4 units. Very good. So that means that our domain is from 4 to infinity. So we should be able to come up with these transformations pretty quickly. I'm trying to make sure I talk over the fans, because that brought the fans here, kind of cool things off. If I'm too loud, that I'm hurting your voice or ears, you got to let me know, okay? I have gotten that comment a few times. Not today, but. All right, natural log function. I'm going to sketch the parent function in order that we can see the transformation. I remember this because I know instead of going through 0, 1, it goes through 1, 0, because it's the inverse of the exponential function. Great. So what's the transformation that takes place here? Down 1 and right 2. Excellent. So the asymptote, instead of being at 0, so this does have an asymptote, instead of it being there, it's over at 2. Instead of going through the coordinate 1, 0, it would be moved over to 3, 0. And then because it's down 1, it moves over to 3, 1. So this should be the approximate graph that you have there. This one looks like it's a little bit more challenging. Notice how I have a negative in the bottom. I could factor out that negative and it would become x minus 2. Everybody see how I factored the negative out of the bottom? Okay. So what's this shape going to be? Things in the different quadrants, right? What's the horizontal shift? Right 2. So my vertical asymptote is shifted to the right 2. What's the vertical shift? Down 1. There we have it. Now, is it going to be in the top and bottom or the bottom and the top?
Left top and right bottom.
Here?
Yeah.
Why?
Because it's
The
negative.
negative creates that flip. So then we're like this and like this. Excellent. Flip it over. Remember piecewise functions? We got multiple functions. Hannah says she was really bad at that. Raise your hand if you believe Hannah was bad at that. Nobody believes you. Sorry. So, We're going to graph these two functions. We've got 3 and we've got x minus 4. So I'm going to graph them in different colors. You don't have to sketch this graph. You can watch. But I have 3, and then what does x minus 4 look like? It's a line with a slope of 1 that goes through -4. Very good with that? So that's the vision I want to capture in my brain. But we all know that they don't go the entire way, do they? One of them stops at 2, and one of them starts at 2. So what I do is I try to figure out my endpoint. So this is my x value of 2. What is the y value all the time? 3. So therefore, I draw my piecewise function until I get to the coordinate 2, 3. So I start here and I draw it until I get there. Is that an open or closed? Open or closed circle?
Open.
Thank you. Why is it open?
Because it's not equal
No
to-
equal sign. Very good. Then I go to the bottom here and I plug in the point 2. If you plug in 2, what's the output?
2.
-2. So plug in 2, you get -2. So that means that this function right here, it starts at 2, -2. And notice it has a closed circle as it goes off in that direction. Right? Uh-oh, we got the scary ones, don't we? With your partner, I want you to try just do the top one on your own right now. Just try the top one. See what you come up with. Go.
There's a shift of plus 1. But x is less than or equal to 0. X is what it has to stop there. This. Yes, this stop here. So this. I'm with you. Oh, but we forgot the plus 1. Plus 1 go up. Okay, so it stops it. So 0. Yeah. It's 0. This one goes up 0 to yeah.
And pause. We should have taken the exponential function and shifted it up 1 unit. Did you have a shift up of 1 unit? Because of the plus 1? I heard somebody say it over here. I think it was Emma. She said it goes through the coordinate 0, 2. How do you know it goes through the coordinate 0, 2, Emma? Okay, so she just said if it's shifted up 1, then it's going to be up there. The other thing I want you to know is if you plug in the coordinate 0, what is anything to the 0 power? 1 plus 1 is 2. So we found that endpoint, and it is a closed circle. So notice the part of the graph that we don't show is that part headed off like that. That's the part I don't show. Okay. For the next part, we just have the natural logarithm of 0. The natural logarithm of 0 is undefined. Just know that the logarithmic function, it just starts and picks up right here. It heads off like so. Okay. So sometimes you can't plug in the 0. You get my point? Like you can't plug it in. There's nowhere. Like if you do the natural log of 0, that's undefined. You won't come up with a value because you can see here that's where the asymptote is. See what I'm saying? But notice it's not where it's equal to 0. See the difference? So you got to pay attention to that piece. Pay attention to that piece. Okay? All right? So, similar to this example right over here, we have the function 1 over x. We have the function of 2, and we have the function of the fourth root of x minus 3. So 1 over x minus 1, going to be shifted which direction? Right 1. So I know I have that asymptote. I might have to erase it, but right now I'm just going to draw an asymptote right here. And are we able to plug in 1?
No.
No, you can't plug in 1. You get an undefined value. That's okay. We know that the function looks like this all the way up until that spot. Then it says between 1 and 3, the function has a height of -2. So what do I do for that? Between 1 and 3, it has a height of -2. Yep. Coordinate -2. And then finally, we have this fourth root piece. Is a fourth root going to look similar to a square root or a cubed root? It's going to look just like the square root. If you plug in 3, what do you get? You get 0, because 3 minus 3 is 0, and the fourth root of 0 is 0. So you can see in this situation that I have the coordinate 3, 0, and you head off to the right. Some of those are pretty challenging piecewise function type problems, okay? And this is just, so the purpose of this is start to get you guys thinking. Before we would test on anything like this, we'd give you more of a review. This is just to really get you start thinking. So here's another thing I like to get you to start thinking about is domain. What kind of numbers you can plug in and what numbers you can't plug in. For example, I have the square root of x plus 2. Can somebody give me an example of a number you can't plug in to take the square root of? -3 would not work, right? Could I plug in -1?
Yes.
Yes, because you're saying that x plus 2 must be greater than or equal to 0. You have to make sure that whatever's underneath the square root sign is going to be positive. So we get x's that greater than or equal to -2. That's my domain, from -2 on to infinity. Is there any restriction for plugging in a number into a polynomial like that? No. I mean, you can plug in any number you want and you're going to get an output. If you think of the graph of this one, it's shifted back 2 units. Does it make sense that the domain is from -2 to infinity? Whereas this graph, it's just a parabola like that. What's the domain of a parabola? Infinity to infinity, or all real numbers. This is a rational expression right here. Irrational expressions you can't divide by 0. So what can x not be in this situation? X can't be 4. So we're going to have an asymptote that happens at that spot. For square roots, there is a problem. Is there a problem for cube roots? No. Remember, the cube root function looks like that. So the domain is all real numbers. Here I have a rational function. So what are we going to think of when we find that domain? What do you have to think about? Don't want the denominator equals 0, so I'm going to factor it and get x and x minus 5. So x cannot be what values? 0 or 5. Very good. And we will stop with that. Let's not worry about the other ones. Really not that big of a deal. And now we move on to, this is going to be the sweet spot for you. You're going to like this. Whoop, I press right. How do I go back to the left? I don't know. Maybe I could grab this and go, do you go left? Huh. All right, whatever. We're going to write equations for lines. This will actually be most important thing that you do over the next couple days is refer back to this piece, because it's one of the big questions that come up with calculus. We'll introduce it in a second, but it says write an equation for a line that satisfies the following conditions. Remember, when you're writing equations for lines, there's really three things that you use. Number one, y equals mx plus b. That is what we call slope-intercept form. Who remembers what point slope form is?
y1 minus y2 is equal to the slope of x minus y.
Yep. And we didn't just make that up. That came from the slope formula. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So those three things we like to use when we're coming up with slope. They're very important. We've seen that before, right? Like if you had a test on that, you'd be expecting 100%. Yes, no? Sweet. So this one's nice and easy. It says slope of 5, y-intercept of 4. So I could just go to this guy right here, can't I? So my equation is y is equal to 5x plus 4. Nice and simple. Question? Okay. Slope of 3 passes through 9, negative 2. Which formula up here am I going to use? Yeah, the second one, the point slope form. I have y, then what? Plus 2 is equal to x minus 9. Anytime I ask for an equation for a line, I always want it expressed in the end in slope-intercept form. So we distribute the 3, y plus 2 is equal to 3x minus 27. And I subtract the 2, and I get 3x minus 29. Are we okay with that? Uh-oh. Horizontal line. Remember, there are 4 types of slope that we have. If I kind of look at this space down here, I use this chart to indicate types of slope. I have positive slope, I have negative slope. What is this? Zero slope, and this is undefined slope. So for these, we have equations of y equals mx plus b. But when we have a slope of 0, do you know if it's x equals or if it's y equals? Do you remember if it's a horizontal line? It's y equals if it's horizontal, and it's x equals if it's vertical. So that's a nice little organizer. It can help keep you straight about types of lines and where they go. So as I move back up here, it says a horizontal line that passes through 9, negative 1. So if it's horizontals, it could be x equals or y equals. Y equals, and what's it going to go through? Negative 1. For the next one, you want to write an equation for a line that passes through 2 points. Every time you hear that phrase, write equation for a line, you can usually always just think about, well, I'm going to need slope, and I'm going to need a point. What point would you like to use, Hattie? She's going to choose 1, negative 4. I like the choice. Do they tell you your slope? Can you come up with your slope? Go ahead. You and your partners, if you can come up with the slope and finish off the problem right now, I will hand out your unit work. Okay, can somebody tell me the equation for the line? Y equals what? Negative 2x what? Minus 2. Is that what everybody got? Let's mark it out here real quick. Negative 14 minus a negative 4 over 6 minus 1. So you add the opposite, you should have a negative 10 over 5, so I get a slope of negative 2. Then you can use your y minus y1 equals m times x minus x1 and come up with what you need. Okay. We're going to skip this one right now for the time being, and we're going to move on to our perpendicular line. What is the relationship between parallel lines? Their slopes are? Same. What's the relationship between perpendicular lines? Opposite reciprocal. So in this situation, if you are looking at trying to identify both the slope and the point that exists on that line. The point, you know, is negative 9, 1. What is then going to be the slope? Negative 1/3. It will be the opposite reciprocal. The opposite reciprocal. Okay. From there, we can go ahead and y minus y1 is equal to m times x minus x1. To be a y minus 1 is equal to negative 1/3 times x plus 9. And you would know what to do from there, correct? Good. So that's just a little bit of a review of functions and graphs, writing equations for lines, kind of prep your mind for where you need to be. There's a lot of things that we could do to review, couldn't we? Like, for example, can anybody state for me right now what the law of cosines is? C squared equals a squared plus b squared minus 2ab cosine of c. So let's admit that we haven't remembered everything, have we? And that's okay. These are the most important things that you need to start off with for skills for the year. You need to know about your functions and their behavior. You need to be able to know how to write equations for lines. And you need to be ready to think analytically, okay? All right? So given that, you can set these notes aside and you can pick out your new homework packet and your notes. We'll spend 2 days on this first lesson, which is basically an introduction right now. And from there, we will move on to then on Friday, you'll have a section that you should be able to do on your own pretty well. But we'll pick up the pieces on Monday if we need to. So I'm opening up to this section, and this is a little bit different for me this year. And it's different in that I have 2.1 through 2.5. I've broken this up many different ways over the years just because of COVID and everything else. But there's certain sections that we'll cover a little bit more in depth and some we won't. It's possible we will actually take out 2.4 and get to it later. I don't really know. I need to kind of feel where we're at as a class. Do you know what I mean? Like right now I look and I see a bunch of super smart and hardworking kids. So I'm like, well, hey, we could add about 5 more sections onto that. But, you know, let's see where we're at. So it's possible we might subtract 1. We won't add any more. Get my point? Okay, so the pre-calculus class today. Remember those days? They asked a silly question today. You want to hear about the silly question? We were talking about dividing by certain numbers, and we brought up this situation. For example, suppose you have 0 over 5. What is it? It's 0. Suppose you have 0 over 1. It's 0. And somebody said, well, if you take 0 and divide it by 0, that's probably 1. And that's tough, because if you think about that, it contradicts a few things that we've discussed in life. Number one, we've said if 0's on the top, it comes out to be 0. Haven't we said that many times? Second of all, we've also said if 0's on the bottom, it's undefined. So we have either 0 or undefined, and you've also been told that if you have the same number on the top as you do on the bottom, then the answer must be 1. It's a tough question. In fact, all of calculus can really boil down to 2 basic ideas. Number 1, what is 0 over 0? And the second one would be, what is infinity divided by infinity? And at the end of the day, you might just want an answer. I have to tell you that if you want me to just give you an answer, the calculus is just out the door. And calculus, since the year 1600, is one of the most important things that humanity has ever discovered. It is responsible for having satellites in orbit and all sorts of other stuff. Changed the world forever once we discovered calculus. And it can really boil down to these 2 ideas. And it's not 1 and it's not 0. The fact is that sometimes it is 1 and sometimes it is 0, but other times it's 8. And other times it's -3. And sometimes it's pi. It depends on the situation. So to introduce that piece, we come up with a problem, a big problem that exists, and it is this problem called the tangent problem. So I want to get to that, but before I get to that, we're going to talk about this tangent problem. It's going to come with writing equations for lines. It says, given a curve with a line tangent, given a point on the curve, I'll actually draw what that looks like. Hey, that's what bothers me is I don't have an undo button on here. I got to press that button, and I got to go here. Okay, here we go. So it starts out like this. If I have a curve, we'll say x squared plus 1. What shape does it make? Parabola shifted up 1 unit, so I'm going to do that. And head off like that. It's a very basic question. It really is, okay? It says, given a curve, and the line is tangent at a given point on the curve, and we're going to say it's tangent for an x value of 1. And what tangent means is that it touches the curve just once at that local spot. So if I go to the coordinate 1, 2, which is right here, okay, I would have a tangent line. Now, I'm not very good at this, so don't judge me, but I'm going to try to draw a tangent line. That's about a tangent line. Everybody okay with that? Okay, great. So given a curve with a line tangent at 1 point, determine the slope of the tangent line. Now, let's think about this, okay? We want to know the slope of that line. And we just talked about slope. And in order to determine slope, you need what? You need 2 points, right? How many points do we have? We got 1. This is difficult because we only have 1 point. I want you to talk with your peer next to you. I want to give you a solid like minute, 15 seconds. I want you to come up with what you think is your best estimation for the slope of that line that you drew. What do you think it is? Talk. Go. Anybody got a general idea, a general guess? Throw some numbers out there. What do you think is the slope? There's not really a wrong answer. I guess if you give me a negative number, I might say, what are you thinking? But it's not going down, is it? So, what do you think? 0.5. Other thoughts? 2. Other thoughts? 1.7. 5? 1.5. What is the slope? I'm going to show you over the course of the next few weeks how we discover the exact value of that slope rather quickly. Right now we're going to take an investigative approach that really brings up an important element of mathematics, and we're going to do something by a process of creating more points. So I want you to follow me here. And again, this is a big idea today, okay? So we're going to visit this again tomorrow, but continue to focus on this idea of finding that slope. I say I need a second point. So I'm going to make a second point. I'm going to look at an x value of 2. If I have an x value of 2, who can tell me what the y value is? 5. Why 5? Because you plug in 2, you square it to get 4, and you add 1 to get 5. Does everybody see that? So my other point is 2, 5. I'm going to write that right there, okay? And I don't have to draw it perfectly, but I'm going to put that point right about there, right about 2, 5. And I'm going to draw it in this green color because it's handy. And I know that you can't do that, but does everybody agree that the green line and the black line, that the slopes are not the same? Everybody agree they're not the same, are they? Everybody agree that they're similar? What the green line is an estimation for the slope of the black line, is it not? It's an estimation. So let's calculate the slope of the green line. If I want to do the slope of the green line, well, I would do 5 minus what? 2 over 2 minus 1. And what do you get? 3. So 3 is an estimation. Would you agree that the slope of the black line must be less than 3? Okay, let's try another one. I want to get more accurate. So what I'm going to do is, instead of picking an x value at 2, I'm going to pick an x value that's closer. I'm going to pick an x value at 1.5. This is extremely important you see this. How do I come up with the y value if I chose an x value of 1.5? I plug it in, and 1.5 squared is 2.25, plus 1 is 3.25. Does everybody understand how I came up with 3.25? Good. Do I now have enough information to determine slope? Yeah, I take 3.25 and I subtract what? 2 divided by 1.5 minus 1. Still haven't figured out this writing thing completely. Sorry about that. 3.25 minus 2, that's 1.25. And then 1.5 minus 1 is 0.5. And I just happen to know if you divide those, you get 2.5. Do people follow my process? Then here's what I would like you to do. I would like you guys right over here, you 5, please do this section right here. Compute the y value for 1.1 and then the slope. You guys here, please produce the y value for 1.01 and the slope. Check with each other. You guys here, produce the y value for 1.001 and the slope. Go ahead and use your calculator if you need to. Take out that graphic calculator if you need it. No rounding, exact values. We're out of here at 24. I want to make sure we get an answer before you guys leave out the door. We got a minute, 40 seconds.
Okay, can we do that? Minus 2.
Check with your peers. Talk with your partners. Compare your results.
You guys are gonna have
You guys have an answer? Excellent. Okay, eyes up here. Way to go. We got 30 seconds. Don't leave, okay? When you computed the slope here, you guys should have come up with 2.1. When you guys computed it, you should come out with 2.01. And when you guys computed it, you should come out with 2.001. So, as this value here gets closer to that one right there, it looks like the slope gets closer and closer to what? 2 is the answer. Who said 2? Mikey Olson. Round of applause for Mr. Mikey Olson. Way to go, buddy. Yeah. Finding slope was the #1 piece for today. We're going to take that big idea, build it in tomorrow. You guys are going to be excellent at your first assignment. You might finish that assignment in class, and you'll be set then for Friday. Way to go. Thanks for being here. Love seeing you guys.
I'll be gone tomorrow.
Okay, I'll post a video.
Okay.